In this problem, our goal will be to transform the Cartesian coordinate -1, square root of 3 into its corresponding polar coordinate. So here we have a Cartesian plane with the x and the y axis, and we have the point P plotted on the plane. It's -1, square root of 3, meaning the x coordinate is -1, so we're lying on the negative x axis, and square root of 3 being a positive value, so we are on the positive side of the y axis. Now our goal is to convert this to its corresponding polar coordinate. For that, what we'll do, we'll join the point P with the center or the origin O. Now, first thing what we can do is we can determine the value of the radius r, which is also going to be the distance OP. The OP, which gives us the distance r, that's going to be equals to, all we have to do is take the square root, and underneath the square root we're going to first square the x coordinate, so that's -1 squared, and that added to the square of the y coordinate, so that's square root of 3 whole squared, and this value comes out to be equals to 2. Then our next task will be to obtain the angle. For this, first what we'll do, we'll drop a perpendicular from the point P to the x-axis and name it A. So we have PA perpendicular to the x-axis, and this gives us a right angle triangle PAO, which is right angled at A. So let's find out in triangle PAO, right angled at O. So here we will try to find out the angle phi. So we'll first find out tangent of that particular angle phi. The tangent of phi is defined as the y coordinate, which is PA, divided by the x coordinates, that's AO. Now PA, we're only going to consider the magnitude, so PA, which is the height, that's going to be square root of 3, and the AO, which is the y coordinate, has the value 1. Well, it's -1, but we're considering the magnitude. So tangent of phi comes out to be equals to square root of 3, and we know that square root of 3, that's true whenever we have tangent of pi over 3 radians. That means for tangent of 60 degree we have square root of 3. Now this is angle phi. What we actually need is the angle theta. Now theta is this particular angle. This is the value of theta that we need. All we have is angle phi. To find out theta, what we can do, we can take pi radians, and from there we can subtract the phi angle. So that's going to give us the value of theta. So we have pi minus phi. So phi we have obtained, that's pi over 3. So that means we have the angle 2 pi over 3. Hence, we have successfully converted the coordinate point P, -1, square root of 3, to its equivalent polar form. So that's going to be the radius 2, and the theta component is going to be 2 pi over 3 radians.